Hi, and welcome to the live demo for Group 18's EC311 project. Our project is a multi-input translator that takes a tilt input to display user-selected characters on the VGA screen. We can move forward to how it operates now.
In order to input a selected character, you select or toggle one of these 6 switches here. To set the character, you push this middle button, which is an enable. The top button is a reset button, which will clear the screen, and the bottom is a delete, which will delete the current character that you're on. We're inputting our first character, and then you'll hit the input or enable button. In order to go to the next character, you'll tilt and then change the characters here and enable again. And then to go to the next, tilt, change the characters, and enable.
So something to note is that the accelerometer has been mapped to some LEDs. So when the input signal is recognized for like a right tilt, for example, the right LED will show, and then for a left LED, we'll do the same thing for a left tilt. So you can continuously change the same position. You can change the character there. So now it's hog, back to dog. You can delete that character, just put the dog back in, and any character you want at the same position until you actually tilt the accelerometer to change it to a different position. So this is the GitHub repository for Group 18's multi-input translator. So we have the full Vivado project in this multi-input translator folder. And then down below in the separated files folder, we have all the sources, simulations, constraints, and the bitstream separated out. So bitstream's in here. And then the constraint file. This is a test bench just for the letter decoder. And the sources for the full project. The GitHub repository also includes the presentations in a PDF and PowerPoint format. And down below is the README file. Later, when this video is fully edited, a link will be included down below as well.
Code for the VGA controller. We modified it to take one of 3 inputs, which are the 3 different letters that we want to display onto the screen. We have bitmap enable areas. These are the areas that we'll want to display our characters. It is decided by iterating through when the pixel that we are currently iterating on is in one of these 3 areas. We look at the current letter that is stored in either 1, 2, or 3, and we find the matching case statement. All of the bitmaps were modified from the ASCII ROM, and they are stored here. Another important part of this code is the bitmap expansion. This makes it so that we only have to store our bitmap characters in a smaller 8x16, but we can display them so that they're a little bit larger.
This is the letter encoder. It uses 6 of the onboard switch as the input. User can type character and send them to the VGA screen. The switches will select letters, and debounded button will use to confirm the logic to be enable or delete. Characters are displayed in the tilting determined position. So the letter management logic is quite simple. There's 3 letter slots, letter 1, letter 2, and letter 3. They're over here. And the switch input is mapped to letter using a case statement. Each 6-bit combination corresponds to a specific letter. And for enable and delete, the enable triggers the addition of a new letter to the next available slots, where you select your own slots using the accelerometer input, and the flag of it is called flag EN. It's used to ensure like only one letter is added per press. The delete signal moves the letter that's pointed by last inserted position. Note that we delete the pointer called last inserted position here because we're using the accelerometer as the input, so it will delete whatever you select using the accelerometer, and the last inserted position pointer is deleted here. It will keep track of the most recent modified slots. That's all.
So this code section detects the rising edge-like behavior in the tilt input signal, and it controls the pointer position. And so when the tilt input is changed from like the neutral state to a specific value, we used 0, 1 for all the way to the right and 1, 0 for all the way to the left. And when this specific value is changed from the neutral state, the pointer or the current position moves left or right within the defined bound. It also ensures movement only occurs on transition to avoid continuous changes. The previous tilt input is updated every cycle to track the last state and enable transition detection.
So this is the accelerometer SPI file, and this was found and written by someone that goes by FPGA Dude or David. We will include the source code and the relevant GitHub repository as links as well in the README file. The only things we changed is the output that we wanted to use with our project. So before it was outputting the X, Y, and Z axes in 5 bits of data, but here it's been changed to only output X axis data, and thresholds have been set such that only 2 bits of data are actually needed. Another thing to mention is within our sources, we also use a debalancer. This is just to ensure that button signals are stable before being used.